Hello everyone, welcome to my Docker tutorial. By the end of this tutorial, you should be able to grab all the concepts about Docker and be able to learn and work with Docker on your own. So first, we'll talk about Docker installation. So there are three ways how you can work or learn Docker. First is play with Docker. So if you don't want to install it on your desktop or on your laptop, but just want to learn Docker somewhere, play with Docker is the way to go. So for this, you have to go to this site called labs.playwithdocker.com, where you can provide the login details for Docker Hub. And with your login credentials, you will get an interface where you can learn Docker. So I logged in and got this start prompt. So when I click start, I should be able to get a Docker playground where I can work on it. So over here, you can click on this add new instance and you'll get a prompt with the pre-built and pre-installed Docker version. You don't have the ability to change the Docker versions because it comes with the pre-installed version, but you'll be able to work on the terminal like you do on your regular laptop. So over here, you have the ability to create multiple instances. And if you want to work with clustering, so you can do that as well. But you have a time limitation of 4 hours. And after 4 hours, your instance will get terminated. So basically you can execute any commands in here. You can execute Docker version, you can execute Docker run, and Linux, like you can just work it as the regular Linux terminal. Another way to learn Docker is to install it on your Mac or Windows. For that, you can go to this Docker site, docker.com, and click on get started. Then you can just click on download for Windows or Apple Mac OS. It's for your operating system. So Docker has this community edition and an enterprise edition. Community edition, which we are using it right now, is free, whereas the enterprise edition is a paid version. But for our learning purpose, we will use the free version where we will use the Docker desktop on Windows PC. And this requires Windows 10 or later and a 64-bit operating system. And you can install this on Mac as well. So Docker for Mac and Windows are developer-focused tools from Docker, which provides you the quick way to create a development-focused environment. And it's just as simple as going to docker.com, downloading it, and just installing it as the normal software. So after installing, you will get this interface like you can see over here in my Windows machine, and you can see that it's fully integrated into Windows experience. Same goes with Mac. And remember that the Docker for Mac and Windows, these are not the production grade stuff where you cannot do any high availability stuff. These are just a simple local development environment with a single instance of Docker engine. Also, Mac natively does not support Docker, so everything is implemented in background via one lightweight Linux VM that has to be started by Docker to run the containers. So even if you are installing Docker for Mac, it's actually using a Linux container. And Windows can do native Windows 32 containers or the Linux container. And this Docker desktop for Windows lets you to switch in between the Linux container and Windows container. But unlike Docker desktop on Windows that we just installed, Docker on Windows Server 2016 is a production grade, and you have enterprise edition is supported in there. So here you see that I have Docker desktop installed by just going into the docker.com and downloading the software. So if I go into my PowerShell and see the Docker version, I can see that the version of Docker that I have installed. And if I just type in Docker, I can see the list of commands that are available to me. So now I can go ahead and start using Docker on my Windows. Similarly, there are multiple ways to install Docker on multiple Linux distributions. So here we are going to do the easiest way with the scripted installation. So for that, you just go to this site called docs.docker.com get Docker and select Docker for Linux. Then you select your distribution. For my case, I have Ubuntu platform, so I selected Ubuntu. And scroll down to the section where it says install using the convenience script. Then copy this one-liner and just paste it in your terminal. So now we can see that I have this getdocker.sh that it downloaded from the site. So now you can execute sh getdocker.sh. It's as simple as this. Then you'll have your Docker installed. As you see, I have this Docker version already installed in my Ubuntu machine. So this is one way to install Docker, and you can use and refer to other ways of installing the Docker on your machine and on any operating system. So as I referenced earlier, if you don't want to install it on your machine and just want a interface where you can execute and learn Docker, you can go to playwithdocker.com and just create your own Docker instances. Now let's discuss about Docker concepts. In short, we use Dockerfile to define the instructions for creating an image, and then we use those instructions to package it into an image. So inside of image, we have all the codes and supporting files to run an application, and images are read-only templates, so we can use the single image to spin a container or multiple containers. So containers can be thought of as a running image, and image can be thought of as a stopped container. All an image has is a bunch of files and manifests. The files includes your application files as well as your operating system and library files and everything that is needed for your application to run. And manifest is a JSON file explaining how it all fits together. So image is this a bunch of layers that is stacked on top of each other. So it looks like a unified file system, and these layers are presented as a single flat image. We take this and we start containers from it, but image is read only. So to write the stuff for each container, we create a thin writable layer and lash it on top of the read only image. So any writes and any updates that we do to the container needs to be done here. So we have one writable layer per container, and image as it's read only, we can spin up multiple containers with the same image. So once you have Docker installed, you can just go ahead and type in Docker info. So we can see all the informations, and we can see information about the storage driver. We have information on the file system and additional information for this Docker that is installed on our machine. Now let's talk in brief about images. So registry are where we store the Docker images, and the main one is Docker Hub. So within a registry, we store images in repositories, and they are divided into these official images and unofficial images. So in theory, anything in official repository should be up to date, and they should be ideally free from known vulnerabilities, and they are simple to use and well documented. And you have to be extra careful when using the unofficial images because they are from unknown source. So we can execute a simple docker pull command and pull the images from the official Docker Hub repository or any private repository that you have configured. So if you haven't configured anything, by default Docker will pick up images from the Docker Hub. So if I go to my terminal and just execute docker pull docker.io slash, let's say, nginx and latest. So here I provided the registry, which is docker.io or Docker Hub, and then I provided the repo, which is nginx, and I provided the image name, which is latest. So this is one important thing to understand, that nginx is not the actual image, it's a repository, and the tags that you provide is the actual image. So by default, if you want to pull it from the Docker Hub, you don't necessarily need to supply the docker.io, and if you want the latest version, then you don't have to supply the tag as well. So instead of executing this pull command, if I want to pull the latest nginx from Docker Hub, I can go ahead and simply type in docker pull nginx. It will go ahead and pull the latest nginx image from the Docker Hub. So in the meantime, while it's pulling images, if you go to the Docker Hub and type in nginx, we can see that we have an official nginx image that shows at the top. So this means that the official image lives on the top of Docker Hub namespace. So if I click on nginx, I can see that it has multiple tags. So by default, you don't have to provide the latest tag. So let's say if I want to pull in tag 1.21, I can simply go into my terminal and execute docker pull nginx and 1.21. So this means that we haven't supplied any registry. So it's going to pull from the Docker Hub registry. It's going to look into the nginx repository where it's going to pull the image 1.21 or the image that is tagged with 1.21. So if I type in enter, it's going to pull the 1.21. So I can execute Docker images, which lists the number of available images that we have in our system. So as you see that I have the nginx image with the latest tag as well as the 1.21 tag that I just pulled in earlier. So as we described earlier, images are the bunch of independent layers. So let's say that we have this image in the host where we have Docker installed. For each layer, we compute its hash that we use as its ID. So we call this content hash, and these are the uncompressed layers with their content hashes. So when we push this image to the registry, we create an image config or manifest, which defines the image, which defines what layers are in it. But we have this uncompressed version in our local machine where we have Docker installed. While pushing, we compress the layers, and this generates different hashes, which are called distribution hashes. And registries, they use this distribution hash to verify that everything has arrived as it should. So locally, you have these uncompressed layers with different content hashes, and on the registry, you have the distribution hash. In Linux, each of these layers are represented in a directory, which is under var, lib, docker, and under the storage driver, which we saw earlier that we have overlay to driver. So if you go in here and do ls-ltr, you can see that there are these different layers. So on Linux, each of these layers are represented in a file system under this var lib docker and the storage driver. So the ID that you see over here are the random IDs. So basically you have these uncompressed layers with different content hash. Then on registry, you have the distribution hash, and under the Linux host itself or the Docker host itself, you have these randomly generated IDs that is stored under var lib docker. Now, if you execute docker history nginx latest, you can see the history behind the image. So basically, when we create an image, we execute some commands, and these commands creates a new layer, and some of them add image to the image config file. So this has list of everything we did on the image. So for example, the information like adding the environment variables or exposing certain ports. You can also use docker inspect command that gives us information about its config and layers. So if I do docker inspect nginx latest, it will provide information on all the layers as well as other informations for the image. So now that we can see that we have two images of nginx. So let's say I want to create a docker container using the nginx latest image. So creating a container out of the image is as simple as running a one-liner command. You can type docker run, let's use the interactive terminal using the nginx latest and passing in the bin bash. So this should create a container and give me the bash terminal. So now you see that I am inside the container. So if you want to get out of the container by killing the existing session, you can just press Ctrl D. But if you want to keep the container running and get out of the container bash shell, then you can just type in Ctrl PQ. So if you do docker ps, you can see that you have a container that is running in here. So if you see the name in here, it just has this weird name amazing chat. So don't worry about this, because these are the randomly generated names that gets assigned to every container you create if you don't pass in any name. If you want to pass in a custom name to your container while creating it, you can just do docker run it and you can pass in a name, let's say test. You can use nginx and you can pass in bin bash as your default bash shell. As you see, I can type in Ctrl PQ to get out of the container, and if I do docker ps, you can see the name assigned to the container that I just created is test. So this is how simple it is to get started with Docker. Now that we understood about the images and how to create the container, let's talk about the Docker architecture. So let's say you have this host with an operating system. So all container is the small area of operating system, which limits on how much resource you can use. We can add one or more containers within the same operating system. So all popular container technologies that exist today, they fits within this definition. To build container, we use two low-level kernel primitives called namespace and cgroups. So namespace is used for isolation, which allows you to take this operating system and carve it into multiple isolated virtual operating system with its own resources. Like it has its own file system, it has its own process tree, and these are called containers. So each containers, they get their own network interface, they have their own user, and to a user it feels like it's a regular operating system, but each containers, they share the same kernel with the host. So I have a detailed explanation video on difference between virtualization and containerization. Please refer to that in my channel. So basically containers are isolated so that stuff inside one container does not know anything about the other container. And then we have C groups, which is used to group objects and set the resource limitation, because we don't want one single container to use all the memory and CPUs. So in Linux, we have these many namespaces, and then container are just an organized collection of these namespaces. So PID namespace gives each container its own isolated process tree, complete with its own PID1. So process in one container is unaware of anything on other container. And the net namespace gives each container its own isolated network stack. So it has its own NICs, own IPs, routing table, etc. And mount gives container its own isolated root file system. IPC lets process in a single container access the same shared memory, and UTS gives container its own hostname. And user namespace, it lets you map the account inside a container to different users on host, like mapping the container's root user to a non-privileged user on the host. So basically these two technologies, namespace and control groups, are what makes container functional. So unless you are a kernel developer or a kernel engineer, working with this low level kernel stuff is very difficult. So that's where Docker comes into play. And Docker, it provides you an easier way to work with the containers so that you don't have to worry about this lower level stuff. So Docker has this Docker engine that makes the low level kernel stuff easy, and Docker engine is core of what Docker does and what makes working with containers easy. So Docker, it exposes with API and it also interfaces with the kernel stuff so that we can create containers easily with all its isolated stuff. So Docker engine is the core of everything Docker provides. So let's understand the workflow in brief. So we have this Docker command line interface where we execute commands like docker run, like we did earlier. And we have this daemon that implements the REST API. So once we execute command, client asks daemon for the container. And then the containerd, which is a daemon process, manages and runs the container. So containerd supervises and handles the execution and lifecycle operation like starting the container, stopping it, pushing and pulling images, managing the storage and networking. And then we have this OCI layer that does the interfacing with the kernel. So runc is the default runtime at OCI layer, and it is what actually builds the container. And runtime is nothing but low-level software component that creates container. So for each container, we have a new runc process that forks it and exits. So in summary, we use Docker client to pass the command like docker container run with certain parameters like we did earlier in the command line. Then client takes this command and posts as an API request to containers create endpoint in the daemon. Daemon then starts containerd, which is a daemon process for managing the lifecycle, and runc runtime at OCI layer gets called, which then creates the container and exits. So basically you have only one containerd process running on a system, which is a daemon process, and runc just starts the container and exits. So now let's go into the command prompt and execute some basic commands and get familiarized with Docker. So let me clear this screen, and now if I type in docker help, it will give me the list of commands that I can execute with the Docker. So over here you see there are certain different commands that I can use with the Docker, and as I showed earlier, you can execute Docker images to see the list of available images. You can use docker run with interactive terminal and you can pick in any image, let's say nginx, and if you don't provide any tag, it will just go ahead and pick the latest tag. Whereas if you want to use any specific tag, then you provide the specific tag and then just execute. Once you are inside the container, you can just execute anything like the normal hosts or normal operating system. So if you do docker ps, it will show you the lists of container that are running. If you do docker ps-a, it will show you the lists of container that are running as well as that exited earlier. So if you want to look at the Docker images, you just type in docker images. If you want to look at the history of specific images, you just go ahead and do docker history on images. So let's say I want to look at the history of 1.21 tagged docker image. So over here, I'll see the lists of commands that are executed in this image. So each image, when they are pulled, they have their own hash. In the local file system, you have this file called var-lib docker, and as we saw earlier, we have this overlay 2 as our default storage driver. So if you go under this overlay 2, you can see the different layers of image that we pulled in earlier. We'll talk about networking and storage drivers as well as Docker Compose in upcoming tutorials. But for now, if you just want a single standalone host where you want to run multiple containers, you can install it on your Linux system or on your Windows system and just run it at the normal system. So earlier we saw that we installed Docker on our Windows system. So this is pretty much similar to how you are working on your Linux terminal. You can just execute docker pull nginx. It's going to go to the Docker repository and pull the latest tag because you haven't specified any tag. So there is nothing different in working in the Linux terminal versus in the Windows terminal. So that's it for today's tutorial. We'll be covering more advanced topics in upcoming tutorial. Stay tuned. Thank you.